Hi, everyone. This week, we're going to focus on information representation, the second part, indexing, abstracting issues. So let's take a look at here. First, what is indexing, right? What's the objective? And indexing really is defined as to construct a representation of published item in a form suitable for inclusion in some type of database. And the reason we care about index, as we said before, because information organization and information retrieval are two sides of the coin. So if you see, in order to effectively retrieve information, we have to understand how information organized. And indexing is a way to organize the published item in a database. So for that reason, good indexing really helps to improve the chances that users can retrieve information. And of course, a bad indexing will hinder the chances of users retrieve relevant documents. And indexing guidelines. And normally when we index, we should include all the topics known to be interest to the user that are treated substantially. So there are two things here. Because it's for information retrieval, so anything might be interest to the user should be included in the index, okay? And also make sure they're treated substantially. If this document did not talk about, if they didn't talk a lot, just talk a tiny bit of it, then it's not useful for the user. Does that make sense? And then, so that's why you need to index each of this specifically and based on the needs of the users. So keep in mind, indexing is for the purpose of information retrieval. There are two types of indexing. One is pre-coordinated indexing, the other one called post-coordinated indexing. And the difference is the pre-coordinated index occur at the indexing stage, and post-coordinated index occur at the searching stage. So one is at organization part, the other one is at the searching. So one example of the pre-coordinated index is book index. Everyone, when you get a book, if you want to search for something, you might look at the back of the book. Normally, that's what the index is. And when they publish the book, they already have the index in place. So basically, the index, the terms they have there, you cannot change. If they did that before the publish a book, then it's there. If they didn't, then it's not there. So it's regardless of what terms you use to search, right? It's only see whether they're there or not. Post-coordinated index are mostly for computer or for online searching. So for example, when you're searching for digital library, you combine the word digital and libraries. So you can combine multiple terms, right? You can combine academic libraries, public library. So that means the index doesn't really have a lot of words pre-coordinated. They are post-coordinated when users start searching them. So that's basically the case. And then let's look at the manual indexing steps, because there are two types of index. One is manually, one is automatic. So manual index means by human indexers. So the indexer need to analyze the subjects about this book or this news article or about this journal paper and identify some keywords they need to extract. But they do not use the words exactly from the documents. Instead, they need to look for standard keywords normally in a thesaurus, okay? Then they choose the index system, then they put in the system. And then the post-coordinated system will prepare them for each term. And then when the user search, they can combine them together, like digital library, public library, and if it's for pre-coordinated system, they have their own system rule. Like if you have a book, they predetermined how those index is going to organized, how words will be organized, and then they put it in a file entry. That's manual indexing. And when you do manual indexing for post-coordinated, there is an inverted file. Basically, inverted file means you can see from here there is this image there, and so you can tell basically you first look at each document, right? You kind of index that to see the terms used in the title, in the abstract, in the document. And then you also, you kind of reverse them. You kind of you no longer look at document anymore. You look at each word and then see which word occurred in which document. So in that sense, then the term is the main, before you indexing the when you first indexing the document is the main organization. But then when you do the in reverse, when it's inverted file, then each index term is cleared there. So then digital, there are 5 article has it. Library has 10 article, and then whatever term. So whenever users search, then they can find which document containing those terms. And a simplified example of a linear database structure is like that. So that just gave you an example of the inverted file. You can tell this document called a 1, 2, 3, 4, 5. Okay, author Smith John and title Care and Feeding of Cats. And this is journal contain that. And this is about the abstract. This is about description. So, and then when you look at the keywords, of course, you can look at the cats. Then all the documents has them. So the listing, all the document has the cats. And then if you look at the cats in descriptors, those are the terms assigned by indexers. Then those normally are descriptors. They all have cats. So again, 3 documents. And look at the cats in the title. There are only 2 of them because one of them is, there are title also 3 of them. And but author, there's also has cats there, 73422. And if you look at it here, the author is Elaine Katz. So there's one with cats. And then looking for Detroit, there are only 2 documents as Detroit as keyword. So that's kind of inverted file is this right side. This is the documents originally. So this way you can find documents containing cats together. Does that make sense? So that's kind of give you idea about what is inverted file. And manual index, normally very time consuming, can tell you have to analyze the document. So we needed something else. So that's what the emergence of automatic indexing. And now mostly, automatic indexing in the online environment, because the huge documents if you just use human index, that's not enough, especially for the web environment. There are millions of documents and there are new documents come every day. So we can only use automatic indexing. The advantage is comparatively it's pretty consistent because indexers might have different sorts. It's low cost, it can be quickly done. And also, retrieve can be more effectively. And automatic index use exact match. They choose all the words in a document. Then they eliminate common function of the words. We call stop words, like those words have no meaning, like a, the, those articles, or off, and. Those are not meaningful words. So we have a stop word, eliminate them because people won't search for them. Doesn't make sense because every article has it. And in addition, so that's exact match of automatic. But there's some automatic index use best match subject. So that means in addition to what we had before about stop words and all those, we also look at the frequency of word, because the assumption is the more frequently a term occurred in a document, they are more relevant than the one occurred less, right? Makes sense? That means this article is about that. The other thing is very interesting is the significance of sentence, relative position of word. In general, if a term occurred in the title is more relevant on the subject compared to a document only contain the word in the text, not in the title or abstract, right? So those are best match. Now, most of the web search engine use best match approach to find a more relevant document. So they have more relevance kind of objectives. So the first page normally are the most relevant document, which based on the frequency, based on the relative position of a word. The automatic index steps is choose all the words in a document, eliminate common words, we talk about stop words, and then compute the frequency of the occurrence of all words in each document except the stop words, because that doesn't make sense. And then you choose a threshold of frequency, select all the terms above the threshold. The reason that important is if we don't have a threshold, then this term, for example, we'll talk about later, if you're looking, create a health related database, and if you have health really occurred a lot of times, then it doesn't make sense if a user search for health, then they find all the documents in this database. So, normally there is a frequency, and I heard before like 7 times or whatever might be around. So that might be more useful. And also in the past, in order for their website to be searched more on the top list, and some of those vendors try to manipulate the words. So you have to, that's another way to make a threshold. It's not the more the better, right? It's also other measures will be considered. The guidelines for automatic index is, you need to make sure the keyword selected representing the document. And the subject is treated in the document. That's important, especially the most heavily treated subjects. And also maximize the probability retrieving. So the purpose is make sure those are the most highly relevant documents are most likely to be retrieved by the system. And when we talk about automatic indexing, we have to mention a very important concept called term weight. That's what I talked about before. Normally, document frequency, or here we talk about a term called the inverse document frequency. So if a term occurred a lot in a document, that's fine, no problem. But if a term occurred in many of the documents in the database, then that's not a good sign, because then you lose the uniqueness of searching for that. As I said, if it's a health database, if you're searching for health, then pretty much health occurred in every document. So in that sense, then the term weight is getting lower. So here is the formula. So the idea you can tell is this formula related to the weight of term in a document. So the more occurred in a document, better. And but it's also look at the term frequency in the number of documents, because basically if more documents has that term, and normally they will put the term down, because that means this one is this is a too popular term in a database. So that's why when you're searching, you also have to consider that reason. Don't use health to search in a health database. And normally the health term weight is also, because when we do best search, and the system automatically assign each term a weight based on the database. And so now the revised step is, again, identify all the terms and delete the stop words, and then look at also word stems. We talk about truncation, for example, dog, dogs, they're same, right? So you want to make sure people looking for dog and dogs, they're same coming from. And compute the value of term weighting, so that then we can make the searching more meaningful. Control vocabulary. And control vocabulary is to make sure the words must be used, in fact, is being described as concept. When we talk about automatic indexing, we don't use control vocabulary. We use the words that the author use. And when we use manual indexing, we use control vocabulary, because we want to make sure we're not just using the words from the author. We want to use the words in the thesaurus, which is the concept. And index could use control vocabulary to overcome the problem, because otherwise every indexers will use different term, and every author might use different term to represent the same meaning. And the problem with natural language using IR is synonym, because when you have a synonym, it's not considered. they'll be in different, coded in different index differently. Sometimes there's semantic ambiguity. I will give example next. And also contextual ambiguity, and also lack of hierarchical structure. So let's see synonyms. We all know, because if you're looking for example, intelligent interface, there are also maybe user-friendly interface, intelligent terminal, search terminal, intermediary. All those terms could be related. But if you just look at the term without consider synonym, then your retrieved documents will be much less, right? And the semantic ambiguity, sometimes they use the same term, but they're different meaning. For example, the play could be a theater, theatrical production, or the children play. When we talk about circulation of air, circulation of blood, circulation of books, they're different. So, but for the system, they don't know the semantic ambiguity. They only see the term circulation, they only see the term play. So that's also problematic. Contextual ambiguity. Sometimes you don't have a context, right? So if you search for work or information theory, but the system will definitely give you this one, said public needs more information regarding underlying theory. This has nothing to do with information theory. The only thing they have similar is they have two terms. So that's why if you're doing automatic indexing, you don't see the contextual ambiguity. So only the index human can identify that. Hierarchical structure. And as a term we talk about here, if you search the use of stories by track and field athletes, and the system doesn't know what track and field means, right? Only if human know that's related to sports. So the hierarchical relationship is not there. That's also a problem with automatic indexing. So the advantage of using control vocabulary is they minimize or eliminate those problems. And they provide a more legal or right words, or the authorized terms for those concepts, right? And they are also artificial language used by index to represent the contents of documents. They normally provide consistency because the index cannot use their own words. They have to use the term in a thesaurus. So what is a thesaurus? A thesaurus is a list that shows relationship with terms. The function, I will give you example later. The function of thesaurus is to find and list valid and invalid elements of vocabulary. They say which terms they would use. They also exhibit a relationship, for example, broad term, narrow term, related terms. So that's mostly for synonym control. So you can tell, you might say in this thesaurus, and this term used, if you want to use zucchini for this term, right? So the thesaurus provide the index with the preferred term to use, right? So especially for related term or synonyms. For hierarchical relationship, and you have vegetables as a broad term, and then squash, then zucchini. So zucchini is one type of squash. Squash is one type of vegetable. So that's from broad to narrow terms. And associated and related term relationship. So you can see how this in this hierarchical relationship are related to each other. So now we're talking about a couple of concepts about used for. So for this one, you can use this one for, right? So it means zucchini parmesan is the official term. So you can use for others, which is not official term. And its broad term is vegetarian dishes. Its related term is zucchini. So you can tell the relationship among those different terms. And here is an example of a term occurred in thesaurus, diet. The scope note is a definition. Diet is regular course of eating, drinking adopted by a person or animal. So, and this does not include diet therapy, right? So that's a different. So diet is only really a course of eating and drinking by a person or animal. The broad term is nutrition. Narrow term diet, Mediterranean. So diet, vegetarian, energy intake, that's their narrow term. Related term is cookery and useful diets. So that means you don't use diets as a control vocabulary, you only use diet. Manual indexing also has some problem, level of consistency, as we mentioned right? Because different indexes might have different one. And index time, of course, very much. You have to read the documents. You have to check thesaurus. Now let's talk about the abstract. Abstract is another way of represent a document. It's abbreviated, accurate representation document without adding interpretation or criticism, unless it's a special type of the abstract, okay? There are types of abstract. The informative abstract probably is the most popular one. Because that one, including purpose, scope, method, results. So when you're writing informative abstract, you have to say what's the purpose of the study, what is the scope of it, what methodology you use, and what's the results. And the indicative abstract is mostly a shorter version of them. You either just put a very much purpose, scope, or methodology. So it's not a comprehensive information as the informative abstract. The critical abstract is more provide comments or review, critical comments or review. Say this article lack of whatever, or they did not provide some of the substantial evidence or whatever. That's called a critical abstract. Special purpose slanted abstract is more emphasize some parts of the abstract. Emphasize on the maybe the methodology part or something special. Modular abstract is different kinds of abstract. They either put together or separate, depends on the definition of the abstract there. What's the criterion for a good abstract? Of course, it has to be concise. Otherwise, people would rather read the whole thing. And also precisely reflect this concept or idea. Accuracy, of course, you don't want to make a wrong judgment. Self-sufficiency. Without reading the article, a person might have idea already what this is about. Clarity and objectivity. Unless you're doing critical, otherwise it should be objectively reflect the content of that. There are manual in abstract, of course, by human, or could it be automatically abstracting. They're looking for some keywords or phrases. They're also looking for some frequency of terms, and also, again, the location of terms, the location in the title or the abstract, in the article, or the first opening sentence of each paragraph, or some of the highlighting the words. So that's all for this week.